Hello, here we are in Advanced Algebra 2. I suppose we're in the 7th, nope, my mistake, the 12th learning target. Yeah, whatever. Hey, look, we're going to multiply and divide rational functions, which basically means we're going to take polynomials and put them on top of polynomials, and then multiply or divide those with themselves, or different versions of themselves. Oh my gosh, let's just do this. Okay, a lot of factoring going to happen. So here's our first example. X squared plus 7x plus 12 divided by 12 times 4 over x plus 4. But I don't know why I read that for you. Hey, let's factor the top. On the left there we got x plus 3 times x plus 4. And on the right, it's nothing to do. I put parentheses around the x plus 4 on the bottom. This way, when I write them next to each other, because multiplying fractions ain't no problem. Top times top, bottom times bottom. Now I can go, pa-chikoom, and the x plus 4's cancel, and then all of a sudden, I'm talking about the 4 and the 12 reducing, and now I have just that x plus 3 over 3. Boom. Okay, that's, hopefully pretty straightforward. Here's the next one. Oh, yeah, gonna multiply again, and boy, are we gonna factor. Okay. So let's do this. X minus 2, x minus 3, and then x plus 6, and x minus 1. Okay, that's the left rational function, or left fraction at this point, really. And then here's the right one, x plus 1, x plus 6, over x minus 3, x plus 2. It's all gobbledygook verbally, really. You just want to go ahead and factor everything, multiply them together, which just means smush together the numerators, smush together the denominators. If you can do it with vigor, it's more satisfying, but it's not mandatory. Okay. Having finally smushed, now I can go kapow with the x plus 6s and kapow with the x minus 3s. Leaving me with x minus 2 in the numerator with an x plus 1. The denominator is x minus 1 and x plus 2. Now, in this case, it might be a little bit tempting to think that, like, the 2's can cancel or the x's can cancel, but in order to reduce or cancel off of a fraction, it's got to be the whole factor of the whole thing. So the 2's are kind of sitting there, like, taunting you, but don't fall for their trap. Hey, to show off, you can make them polynomials again. This part isn't particularly important at this point. In fact, it's kind of counterproductive later when we do the graphs, because in the graphs you want them factored so you know how to make the asymptotes and wholes, etc. But here's the third example. Okay, now this one, oh my gosh, we're going to divide. Okay, so, do you see that first thing? X cubed? Alright, let's get to work. So, we got to do factors of 24? Ugh. Because the constant is 24, the leading coefficient is 1. So we got like 1, 2, 3, 4, 6, 8, 12, 24. Okay, yeah. Plus or minus. Hey, at least the leading coefficient is 1, so we don't have fractions to worry about too. And if you do this, you'll get some winners at negative 2 and negative 3 and 4. Well, that's 3 factors, which means that's enough to make it work. Meaning that original cubic can be quickly factored, x plus 2, x plus 3, x minus 4. Boom, boom, boom. Okay, now, let's go back to, okay, that's off, in a way, like a silly cell phone sign. Okay, now, let's do this. So, on the left, we got x plus 2, x plus 3, x minus 4. Okay, that's the cubic obnoxiousness. On the bottom, it factors pretty fast, still divided by... Okay, now, you see how, like, that top one on the right is backwards? I'm going to factor out the negative sign to make it look correct. So, it's positive x squared, negative 2x, negative 8. I factored the denominator. That's pretty easy. So, I'm going to do it again, and this time actually factor that top right polynomial. Of course, if you were doing this, you might just cancel it off where it's written and write a negative and rewrite the things, of course. but I'm trying to show you each little piece by piece here. Okay. All right, now I've got them factored, and they're still divided. Now, hopefully you remember, and if not, hey, I'm here to help, that if you're dividing fractions, that's the same thing as multiplying, but you turn the second fraction upside down. They call that inverting and multiplying. So x minus 5, x plus 1 now becomes the numerator of the second fraction. And then x minus 4 times x plus 2 with the negative sign in front becomes the denominator. Now that we're multiplying, now we can smush everything together. In fact, I highly recommend it. Oh, goodness, goodness, goodness. Here we go. There's the numerator. There's the denominator. Oh, there's that negative sign because we had it there. Yep, okay. Here we have it factored now. Let's cancel. The x minus 4's cancel, the x plus 1's cancel, and the x plus 2's cancel. But that leaves us with some stuff still. So, up top we have x plus 3 times x minus 5. On the bottom we have x plus 5. And if you want to write them as a polynomial again, kind of redistribute, you can. Although the truth is, for our purposes, which eventually comes back to that graphing business, keeping it factored is perhaps better. Okay, that's it for the examples. It should feel fairly straightforward. This third example has the most action here. Sometimes they're going to be unpleasant, and you have to go back and do work on the side in order to factor it, like the top left. And we've got this division thing, which means you have to flip it upside down. Shouldn't break your head too much. Hey, we've got these to do in class next time. Number 45 itself will be a bonus. I recognize, of course, that you could conceivably copy from your friend who's either smarter or more dedicated than you. But the truth is that I think that if you're thinking about it while you're copying it, there's still value in noticing what's going on in 45. That's it for now. Thank you for watching, and as always, let me know if you have any questions.